Where do you want to start streaming? Um, not. Yes, I see that. Okay, go ahead and switch over. Okay. Hey!
What has science done?
Hello, everyone. Welcome to everyone. I don't know how many people are there. Welcome to a special weekend version of Endgame. We rescheduled it for today because we had some technical difficulties this last week on Wednesday. So we're here Saturday evening. It's a pretty cozy crowd today. So I think this will be probably a bit more of an informal discussion since we don't have a whole bunch of people to wrangle. So the lovely folks that are here, feel free to jump in at any point. We're going to be talking about science communication and basically how we talk about science, how we learn about science. I'm joined here by Dojo Mojo Moto, and
Hello?
I guess as a way to get started, why don't you introduce yourself, Dojo?
Um, well, I'm just kind of a regular viewer of Endgame, who reads too much on the internet. I'm
How much is too
not
much?
real. Good question. But, yeah, I'm not an expert in the field or anything, but obviously, probably like a lot of viewers, I've always liked the different science related shows aimed at the general public, Cosmos, Nova, even MythBusters, and so on. But
But your background is not in science, correct?
uh, no, I typically do IT for a living.
Mm-hmm. But it's something that you study in your spare time, I guess. When did you start doing that?
Uh, I couldn't say, like, for science communication or
And like,
general topics.
when
Like
did you
I
start?
just
How old were you when you started having an interest in science? Oh, hey,
I guess
Stoker.
I guess I was kind of brought up in it. So
Oh,
yeah, my
were
dad
you
was
like your
always into
family?
sci-fi, and yeah, my
Hmm.
dad has a degree in chemistry that he went on to get a degree in computer science in. So always brought us up watching sci-fi and trying to teach the importance of a scientific background. So I guess it was kind of inevitable. Some would rub off on me.
Yeah. Um, I I have a bit of a background in science. I have a bachelor's degree in biology, and so it's something that massively appeals to me, and I have a passion for. Although it started for me, that started later in life. When I was in
Mm-hmm.
high school, I wasn't interested in science, and I feel like that's kind of related to the topic because once I got into college and I started talking to professors and reading different kinds of books, I don't know, some sort of change occurred that I was able to look at the information I was learning and have a personal relation to it where like it finally clicked like, okay, this describes the reality, the physical reality of the world that I live in, and like this is something that I'm a part of. This is something that like this universe that I'm learning about, like I'm a part of it, and the all the biological information, like it describes me and it describes everybody I know and things like that. But there was something about that I didn't get at first. I took chemistry in high school, I took physics in high school, and none of it was, I don't know, none of it was really like it wasn't engaging yet. And I'm not sure, that could just be a personal, like a personal
Yeah.
flaw, but it might also just be a symptom of the education system. I'm not really sure. What were your experiences in school with science?
Some of it I was happy to get into, and some of it was also kind of very dry and by the
Mm.
book, unappealing. Just throw a bunch of equations at people and tell them to go do them overnight.
Right. Um,
So
Sorry, one
yeah,
second.
I
I
think
apologize. I have the wrong avatar.
oh, that's fine. Yeah, the more engaging things, yeah, we're always kind of more the science entertainment, like Popular Science magazine and that kind of thing for me. Where yeah, in the classroom it was a mix of good to finally understand certain things, and also a lot of things are just sort of there in the curriculum and you have to choose through them.
Yeah, yeah. I'm
So you're
curious, uh, real quick, in the audience, is there anybody who had any particular experience with their science classes in school? Were they really, really boring? Were they really, really interesting? Like, what are you guys' experiences? Uh, Opal, did
Well, I
you?
had fun.
Oh, fail. Go ahead.
Yeah, I had a really good physics teacher for high school. So yeah,
How did
I
he?
mean,
How did he? What was good about him? Or her? What made it interesting?
let's see. Yeah, he just brought the energy into it. I mean, he brought a lot of experiments and demos too.
Hmm.
Like that's something I missed in high school. I mean, not in college now because they rarely bring anything into class outside of labs.
yeah.
Oh, I'm a
Oh, I
physics
see.
major, by the way.
Oh, you're a physics. So you're in college right now studying physics.
Yeah.
That's great. What is your eventual goal with that? Are you studying physics because like, are you more interested in the subject, or is there something in physics that you want to do later on in life? I mean, or both. Which one
Actually,
would
I
you
really
say?
want to get into engineering. It's that I didn't
Mm.
click into their path, and I stuck in the physics path for now.
Oh, I see. Is it?
Yeah,
I mean, the two are pretty related, though, right? Because you can't be a good engineer unless you know the mechanics of the system that you're engineering, right?
true.
I find that that's true of pretty much any system, and it seems particularly poignant when it comes to our technological, like our modern technological systems. Um, they're very much built on scientific principles. I was in like the food industry and the medical device industry earlier in my life, and one thing I noticed is that like to develop and to innovate and everything, it's always dependent on um, doing research in journal articles and academic articles, and like to progress. We need to continually build on this body of work. Although sometimes, communicating that body of work and what science is about is sort of a challenge. Jojo, you
Hmm.
picked this topic. What do you think is important about science communication?
Uh,
What interests you about this?
yeah, well, I think it's really important to be able to inform people better about scientific principles and the findings of science in a way that's engaging and correct. Like Phil alluded to in his experience, I also found some of my best teachers were the ones who were the most enthusiastic and brought
Mm-hmm.
more concrete, relatable things to the classroom to demonstrate. And
Mm-hmm.
had a chemistry teacher who was very much into demonstration and adding humor to the lessons and so on. I think a lot of times in science communication, what we some of the things that make a good scientist also kind of make it harder to communicate with the public because people don't
There we go.
or like scientists are trained not to jump to conclusions on things or make too much out of a possible correlation. So a lot of the
Right,
language
right.
they use lot of the language they use may hedge a lot of the implications that they're saying, and they they really don't want to give people the wrong impression where the more entertainment focused science communicators may admit that they're speculating, but also go out and sort of project a bit and say what something might mean, or uh, yeah, essentially that they're willing to take a more conversational tone and use more anecdotes as opposed to numbers and data that have been crunched through more examples.
but that's tough, right? Because I mean the institution of science is specifically built to not be about anecdotes and not to be about stuff that's entertaining. It's almost
Exactly.
designed to be completely boring because you have to have a repeatable experiment. You have to do it
Hmm.
over and over again. You have to replicate results. You have to tabulate tons of statistics and numbers. It is hard to make that
Right.
entertaining.
Right. And so when you're done a study, you have a whole lot of data that's been crunched and analyzed, and you can point to certain statistical correlations, but a lot of people don't really relate to that unless they're trained in the field. And so
Yeah,
even though it's less meaningful, if you give people, an anecdote or something, and maybe make a reference to how large the study was, they might understand it better, or it may have more resonance with them.
I think there's a
And so
specific
that,
track that the information follows where like uh, a a um, a scientist, a group of scientists will publish something in an academic journal. It'll get peer reviewed, pretty much behind the scenes where no one else can see it or know what's going on, and it finally gets published in some journal that you have to pay to get access to, and
hmm.
then some like some science institution somewhere or science publication somewhere, like maybe Popular Science and other things like that. They'll take the findings from that journal and they'll like try to condense it as much as they can and make it interesting for their readers, which are kind of a niche group. And then from there, the more popularized articles will take the information that they find in those magazines, and they'll extract
Hmm.
pretty much the clickbaity information that they can get from it
Uh-huh.
because that's what sells. And when we were talking about this, let's see, you mentioned the what was the name of that effect that where people think that they know more than they do about a specific subject?
Let me see. That was the easiness effect.
Oh
It was
yes, yeah, yeah.
written about as a possible problem that if a concept is explained maybe too easily, someone may overestimate their own understanding of it and use it to second guess expert opinion, and
Oh, so
even
speaking
even
of which,
contradict it.
does anybody, so who here can tell us what the scientific method is, or what it comprises, what it consists of? Does anybody have like a solid like they know that really well? Ooh, we're not getting anything.
I
All
don't know.
right,
Well,
here,
That's a good caution.
yeah, yeah. I mean, and that's good. Like caution, in or that hesitance to be confident in information. I think that also has a name where like the more you know about a subject, like the more you know that you don't know, and so you're not as confident about things. Um,
Hmm.
I don't know. We'll see. So this is if you can see the slideshow here. We found this diagram about the scientific method, which is like it's what science is based on. It's there's a few different ways to say it. Like it's not always in these terms or in this uh, like these specific wording, but it has the cyclical process that is like for the most part it's a relatively dull process. You have to make observations, think of questions about your observations, you formulate hypotheses um, about whatever it is you're observing. And often this involves hypothetical models, so like theories about the way the universe works. So like Newtonian physics is an example of a model about reality and the way reality works. And it's something that was hypothesized and then underwent uh, testing. And testing has to fall under it has to be predictable and it has to be observable. So
Uh,
basically, if you have a model that can't be observed, you can't test it. Were you
yeah,
shrinking.
saying something?
I think those two steps might be some of the hardest parts as well.
Mm-hmm.
Trying to come up with a novel hypothesis to test, and then trying to design an experiment that would successfully measure it. and not lead to false results.
Right. Because the measurement is the part that like um, that's kind of crucial for science. Like if it's not measurable in any way, then it can't be part of the scientific method, and um, it can't be included as the body of scientific knowledge. And something about like the thing about being measurable is that it has to be you have to account for all the variables that could affect any particular piece of data. And so that's about gathering the data to test your predictions. You have to make sure that you're gathering the right data and that you're measuring it appropriately. Um, and so interpretation is kind of part of this gathering data and developing theories. You have to interpret the data, and you have to do that with a bunch of math, and you have to do that with like reliable reliable structural information, um, and and then you continue, and it goes on and on and on, and uh, so this scientific method is something that's kind of crucial to be taught as like this is what science is, this is what it's based on, and I think it probably doesn't get conveyed in like the popularized science avenues, right? Or I mean,
Yeah,
what was your experience with that?
yeah. So this part's obviously very important to doing proper due diligence and going through the rigors of successfully proving or disproving a concept. But it may tend to lose people more in the popular audience when it's presented as systematically as it has to be.
Right,
And
right.
that kind of reminds me of a of one program that's been criticized somewhat for its science. I guess it's science rigor, but has pulled in a very large audience. I'm betting most people in North America here have seen MythBusters,
Oh
and so a lot of the
yeah.
things they
Can you
do.
talk a little bit about that, maybe for someone who might not be familiar?
Uh, yeah, essentially, I believe they're two Hollywood special effects specialists hosting. Uh, run 100 trials of every test.
Don't
Is
forget
that
the
But
explosions.
I think one thing they do.
oh, they have to have explode. Oh, okay.
but I
Well,
had it running continuously.
there is a bit of a delay. Um, yeah, go ahead and continue. Toaster can figure it out. He's a good engineer. uh, okay, so what other so what other so you mentioned MythBusters. Are there any other pieces of popular media that you find notable that are particularly good at conveying the body of
Yeah,
scientific information?
yeah. I think one very famous example. I haven't seen a huge amount of it, but it's Carl Sagan's Cosmos.
Mm-hmm.
It ended up being an introduction for a lot of people,
I love that
Yeah,
one.
yeah.
including I think that was one of the things that inspired Neil deGrasse Tyson, and he ended up making Sagan one of his heroes and went on to do his own Cosmos series.
Right, right. So I mean, that's cool. And Sagan was kind of the previous generation. So like he came around
Hmm.
before the internet and everything, which I think probably makes him a little bit more obscure. Like, I don't know.
Yeah,
If you go on Reddit, everyone knows who Carl Sagan is, but I think maybe the younger people that are around today probably aren't going to be as familiar. But the things he inspired, right? Like he had an enthusiasm about it, and we kind of mentioned before that like enthusiasm for the information
right.
is kind of infectious.
Yeah,
Um,
I think I had to mention him because he seems to have really kicked off a lot of the current style and tone in communicating science and popular culture.
yeah. Here, our next. Oh, where is that? Um, um, so I put together a few of the ones that I'm familiar with that I find pretty notable. Carl Sagan's
Right.
there. And when we were talking, you mentioned David Attenborough, which he's obviously a
Yes.
biology enthusiast, um, along with Steve Irwin, who, man, talk about enthusiasm. Uh,
Hmm. And
which
you see,
are,
in all these people seem to have great passion for what they're doing.
mhm. Do you have a preference? Like, when you're learning about these things, do you seek out material like this more? Do you seek out academic material more? Where do you go for your preferences?
I guess it depends if it's like a specific interest or general, because I just tend to keep a subscription to a lot of these guys just out of entertainment value, and
Right.
they'll tell a random interesting thing. But yeah, if I'm trying to learn more about something specific, I guess I go more for the papers. But these guys a lot of times have the hook to really get curiosity going.
Mm-hmm. Does anybody here have a favorite like science enthusiast, science media type of thing?
I really like Kurkusakt in a
Mm-hmm.
nutshell.
Hmm.
That's on the
Yeah.
picture there.
Yeah, he
Like
uses
their
Yeah,
production
Kurzarak is
value
also
is
one of my
phenomenal.
favorites. Phenomenal.
Oh, oh, sorry. Like, you were piping Zarni's audio through your mic. What were you saying?
What? What?
Did you did you have something to
so,
say?
so
I agree with Zarni. Yeah, Kurzarak's also one of my favorites as well.
yeah, I notice he uses a lot of very
Oh, Michael, if you
sorry.
wouldn't mind muting me when you're
We're getting
we can
feedback.
hear ourselves.
Getting feedback.
Did that do it? No. Sorry, what were you saying, Kurzgesagt?
Yeah, I notice he tends to use very slick visuals. He does like very animated, clearly drawn I guess visual aids for whatever he's describing. Tends to throw in a lot of in jokes and references for people just to keep them interested.
I
So
noticed on
I,
the description, the video description for that channel talks about, or he mentions that they put out one video a month, and that they prefer, to make quality over quantity,
mhm.
which in this, I don't know, in this media environment, has got to be something of a challenge because like the entire entertainment ecosystem right now is like built off of clickbait and like getting as many viewers as possible in as short a time span as possible. I mean, that seems like Do you ever worry about that? Like the body of knowledge that we have, is it threatened? Like how threatened is it by this wave of pop culture information that may or may not be accurate?
Boy, that's a tough one. I mean, I guess if anything, they should be diluting it with incorrect info. But I think for a channel like that, I guess once they drum up the interest, as long as they're fairly regular and people don't forget about them.
Well, the problem nowadays too, there's too many self-proclaimed experts.
Right.
Uh-huh.
Yeah, we've got the easiness effect that Dojo mentioned, where when you have some knowledge of something, you don't necessarily know what you don't know, and so you think you're an expert. There's also the Dunning-Kruger effect, where you overestimate your own capabilities in whatever discipline you might be in. I don't know. It
Each in the
seems like
same
there's a lot
family.
of stuff. Yeah, it seems like there's a lot of stuff working against it. But like, I'm curious if any of you like. I'm sure you're here. You have an interest in technology and discussing like the reality of the world. Like, what techniques do you use to weed out the good information from the bad information?
That's a hard question.
Yeah.
Very.
Maybe
Yeah.
multiple sources, that kind of thing.
Even then, you can't be 100% sure. You just take everything on the internet with a grain of salt, realistically. That is the best way of doing things, is just never fully accept the information for what it shows. There's usually always something more or something like that. And that does tie back into science, because you never truly know if you know everything.
That's
So
true, and
I'm
that
just,
is true about science. Like science is built off of the understanding that, right, that we don't know, and in fact, science, the entire goal of science is to prove ourselves wrong, is to prove our hypotheses wrong, is to like gather information that gets more and more accurate over time. But there's a challenge in like just in personal understanding, right? Where like if you don't believe or if you don't necessarily like buy into what you're learning, how do you build a body of knowledge? Because knowledge needs like previous knowledge to build on top of. Like you have to understand basic physics mechanics before you can understand quantum mechanics. So where's that? How do you, Stokel, what is your take on that?
I'm just trying to think of an answer for that. It's for
Yeah,
each person, it would be different depending on the culture they lived in, their just everyday lives and stuff like that. So each person has a slightly different understanding of science and different other things in their life that is strictly up to the person. So my understanding is really different from yours. So I'm trying to figure out a way of interpreting or explaining. Yeah, give me a minute. I'm gonna think about it.
Okay,
Sure.
sure.
Well,
But
your
science is
knowledge is only
science.
as good as the source where you got your information from.
Yes, that's a good one. Yeah.
Yeah, it sounded like what you were saying a bit earlier was essentially that you maintain a sort of skepticism from any source that you read, and sort of keep your understanding tentative, so it could always be revised.
Yes.
That seems like a good habit to get into, but I think that in itself makes it difficult to communicate then, because if you're not entirely sure about the knowledge that you have, if there's always some doubt there, it makes it that much harder to convey information to the next set of people, which I feel like is just kind of interesting as a, I don't know.
Yeah.
This is off topic, but like one of the patterns I keep seeing in the world is that like the forces for good, or like the forces for like improving our situation and making things better, and like accessing more and more reliable information. There's so many different variables and pieces of human nature that work against them. Like we have to work against ourselves. We have to work against our own desire for entertainment and drama if we want to build a body of knowledge. But that's our natural impulse, and That's
Yeah, and
I think that's kind of interesting.
yeah, I think along the lines of what you're saying, in science communication as well as just political news, we're seeing a lot of the effect of misinformation being spread nowadays. So even if you can spot a lot that isn't credible, you kind of get more of a general idea that the topic in general has a lot of non credible data in it, and take it, I guess, less seriously.
When you
Yeah,
say
like the
data,
sheer
do you mean scientific data?
Uh, yeah, possibly including scientific data, but also communications about a topic in science. Uh, One thing I was going to get into was the actor Alan Alda, actually, Hawkeye from MASH. If anyone's seen it, he he has these workshops to train scientists and PhD students to communicate with the public better. And one thing he was talking about as a problem is in one of his videos was that um, uh, when talking about something like climate change, they'll get a scientist up there presenting the synthesis of a bunch of data they've studied and talking about correlations and trends, and leaving a lot of people kind of scratching their heads or not quite following, but the people on the other side denying it come up with a quick conversational, snappy presentation, make jokes, give it in a very relatable form, and so people tend to come away with a more positive impression of it. And so,
so the form that the information takes seems pretty important to like the way we receive it, I guess. Like you can't.
yeah, if you're not cutting straight to the numbers, people tend to get like an overall impression of the presentation they get. And so what Alda does is he basically puts these scientists through basic like acting camps and has them do improv exercises like you'd see on Whose Line Is It Anyway, or other improv shows.
That
And
sounds
basically gets
fun.
them.
Stick a bunch of scientists in a room and have them do improv together. I like that.
Yeah, and he's shown a lot of them tend to start off very stiff and very by the book, but they get more comfortable with the audience, and they get more comfortable using things like metaphors or bringing in examples from real life, and they tend to give much more human presentations by the end of it.
I imagine learning how to tell stories is going to be a big part of communication, because we're so like that's how we understand things, is through, I think, storytelling that relays the context that we understand things through.
Right, and that's exactly one of the things that he tends to focus on. Because data versus anecdotes. The data might be more meaningful in a concrete sense, but it's not as relatable.
Then there's the sciences you'll never hear about either.
What do you like?
Most
That
probably.
just aren't interesting enough,
Corporates,
or what?
corporate secrets, sciences
yeah.
that are being monetized or going to be monetized. Pharmaceuticals, perfect example.
Totally.
Military finding new and improved ways of killing people. They don't leak that out much.
Right.
Yeah, a lot of proprietary stuff.
Yeah,
You
there's a economic benefit to keeping all the information there secret under a non-disclosure agreement, because they make more money that way. Just another pattern, just working against I think the transmission of knowledge. And
you probably hear maybe the least in public science about people verifying the findings of other studies, but they're finding more and more so that there's not really enough of it going on.
That is interesting. Like a topic that's kind of it has been kind of big for a while is GMOs, genetically modified organisms, and the debate about whether they're safe or they're not safe. And there's evidence that they are very beneficial in a lot of ways, but a lot of people are saying they're unsafe. But the interesting about that, and when I read about this was a few years ago. I don't know if things have changed, but the GMOs are intellectual property. And the thing about that is that you can't, like any scientist that wants to validate or verify whether the genetically modified material is safe or is not safe, if they want to test them, basically. Lyco? Oh, Lyco? Sorry. um,
Just echo again.
yeah, he was speaker. Where was I? Oh yeah, they have to enter an agreement with the company that owns the intellectual property. So the company basically says, okay, we'll give you permission to test these, but only under these circumstances, and we control, like we control what gets published and what doesn't get published, and so like we have to review all the information before you publish it because we own the intellectual property. So we can't let you, we're not going to let you relay information about it without our permission. And I know that is that's a problem. There's a conflict of interest there, right?
Yeah, and that's a field where we've probably seen some great failures in science communication because of things like that as well. Because that doesn't limit the flow of information. It just maybe makes people panic or come up with their own theories about why it is. And
right.
There's a lot of talk of possibilities in it, which can confuse things. But at the same time,
and that's when like a single entity has control over what information gets distributed or not. Like you can't answer questions about it. Like if someone has a question, okay, does this, is this material going to cause allergies? And then the company doesn't let anybody publish anything about the allergenic potential or lack thereof. Then there's just an absence of information, which I think.
Yeah, it's like when any industry says, well, our studies show that what we're doing is perfectly safe. People kind of question it.
Yeah, because they obviously have
no
an
data
interest.
out there.
They want that information to be revealed. I wonder why.
What information?
Exactly.
Like they want to disclose it. Why don't they like to share it? Is there monetary purposes or something?
Yeah, so these companies that make, so like one of the companies that makes genetically modified food, they're selling this food. They're selling it. It's billions and billions of dollar industry. They want to be able to sell their product.
The other companies won't copy it or something, like Chinese companies. Okay.
Yeah, anybody. Yeah, if they hold the patent on a gene sequence, they want to, and it's beneficial in some way. They want to make money off of that for as long as they can, and so they'll hold on to that as long as.
Wait, if they hold the patent on it, why are they still worried that if other people is gonna get their product, they can just pay for the patent anyway?
Well, wait, I'm not sure what you mean.
They can pay for the patent if they're copying.
If the patent's up for sale, some companies will not sell their patent. So
Yeah, I don't think
gives them exclusivity. But then also,
Right.
like you take a country like China, they might just ignore the patents anyway and do whatever the hell they want.
Yeah, and so there's politics involved in that.
Of course,
I think one catch-22 in that issue as well, not so much in the research but the labeling, is how a lot of these companies push very hard not to have labels on the end product that goes to the consumer that says there are GMOs in it, because they know that for now people will shy away from buying it. But at the same time, it also looks like a cover-up to many, so they're even more suspicious of it.
That's true.
It's
Although I think in the U.S.
kind of a bad feedback loop in public acceptance.
I think in the U.S. recently there was I think there was a bill passed that like regulated or mandated the use of labels to say when something contained GMOs, which honestly, like tons and tons of material contains GMO because corn is a heavily GMO product, and there's corn in freaking everything. Like anything that has corn syrup in it, which is basically everything. But yeah, the conflicts of interest, financial conflicts of interest, are usually, not they're not part of the pattern of the purest science is going to be one that doesn't have. Here, I'll go back to the last slide. Is one that doesn't have a interest in any given hypothesis being true. Like it's interested in the pursuit of truth as pure as possible. But we live in the real world, and that's entirely very, very difficult to pursue that. And when I took a philosophy of science class, that was brought up as one of the there's always going to be a rift between science's goal and science's implementation, because even the most dedicated of scientists are usually going to end up having a desire for results to turn one way or the other, because humans are humans, and we have, we exist in a context that has, the different variables mean things, and yeah, it's complicated.
The way I look at it, it's kind of like when you mix
Mm.
when you mix corporate with science, then all of a sudden science may take a shortcut here and there to show off
Hey, Gary, we're in the middle of a show.
profitability. And they'll take a shortcut, and they
What?
don't know what's going to happen by taking this shortcut, but they take it anyway.
Yeah, and that's, but on the other hand too, I mean, economics can greatly, can be a very motivating force in developing new technologies and new, beneficial technologies. I think sometimes as a side effect, but, often, for example, the patent thing, patents expire. Eventually, the information that's the information that's in that patent eventually, and there's always laws and lobbying to extend that, but eventually that will be available for people to study and to experiment with. So there are, there are structures in place that can help enable the free transmission of information, but the other thing is too that everybody has to kind of keep working for that, because the lobbying and the economic factors lean towards making things secretive and keeping patents and IPs as long as possible. And so something that is kind of crucial is that people have an interest in science, they understand what the process is, and they have an interest and a desire to continue science in as pure a form as possible.
So if I could jump to another related subject here, we've looked at direct, I guess direct communication to the public for science communication, like videos and class instruction. But one thing I really wanted to touch on was what's known as citizen science as well, where it's actually been going on in various forms for a long time, with things like counts of different butterflies or different insects in an area, or
Right.
one we hear about sometimes is like submissions from backyard astronomers who discover a new planet or system.
Right, yeah. And there's
And-
apps that exist that can help people participate in these things, right?
Yeah, so a lot of people have probably heard of folding at home, like anyone with a PlayStation 3 for sure. That basically throwing a whole lot of computing power on a large distributed network to crunch the numbers on how different proteins fold for medical research. But there's even been some efforts to gamify it. Like I found this one called Fold It, where they basically give you these proteins as puzzles for people to solve, and several novel solutions have come out of that already. Just rather than trying every possible combination, giving it to people as a puzzle.
I love that idea. I'm curious about what that looks like. That sounds like it could be really interesting.
Yeah, I can try to find it. I can try to pull it up and get it into the show notes for this
Yeah,
on our Discord.
we can link it on the
'cause-
Discord.
Yeah, because sometimes ignorance can be bliss, for the simple fact it's like a child. You give them a computer. We are taught, hey, this cannot be done. They don't know this, so they do it.
Oh yeah, that's actually, I read something once about security, computer security. People build security around the idea of malicious hackers, but there's a ton of instances where children break
I
security
got an example.
stuff all the time, and yeah.
I think it was a 5-year-old managed to bypass the parental lock on his Xbox 360.
Yeah, I think that was one that I read about.
Yeah, when I saw that, I was like, oh my god, that's funny.
Yeah, because
The one person you're supposed to be blocking with that found their way in.
Right.
I'd
Security
And
designers
he
don't
even
know how
got
to think.
credited as a security consultant.
Oh, nice.
Nice.
That's cute.
But, Yeah, another citizen science project some people might have heard of was after the Fukushima disaster in Japan. There's this network. I don't know if they existed already. The project was called Safecast, and they essentially had these little kits or even pre-assembled like data logging Geiger counters that they could distribute to different areas. And I know now they're also doing air quality sampling, and they basically have a large online database of samples from different sites, so you can pull up a map and see what the radiation and air quality is in a given area at a given time.
Oh, that's interesting.
And so projects like this can get a lot more people, without a degree necessarily directly involved in collecting data for scientific studies.
Yeah, I've used one called, I think it's just an app called Naturalist or iNaturalist or something, that I used it to track whenever I found an insect. They had specific insects to look for, and you'd find an insect and take a picture of it and say, I found it in this location, and it helps track the location of insect populations. So yeah, this crowdsourcing thing seems like a good way to get people like personally interested in the process of scientific discovery and gathering information.
It's mutually beneficial.
Yeah, that sounds great.
I'm wondering what sort of things like that anyone here has seen or gotten into that they like
does
the idea of?
anybody know of any that we haven't heard of? Maybe not. We'll have to go out and find some and link it. By the way, for anybody here or viewers, if you want to join our Discord server where we'll like discuss this stuff further, go to endgamevr.com. There's a link to our Discord server. You can find us there. Yeah, so if you have any further information about citizen science, and that sounds, I like that sort of thing. I like citizen science, citizen journalism, open source, like all these different crowdsourced solutions to things seem like a good push in the right direction.
Yeah, they don't always start with the credibility of an established institution, but in time they can prove themselves and gain a reputation.
Yeah.
With
Okay,
the
well,
crowdsourced stuff, just wanted to quickly say, like I said earlier, that I liked Kurzgesagt in a nutshell, and they're currently funded, I think, primarily through Patreon. So you were talking about earlier, like in the state of today, that like everything has to be mass produced and consumed quickly, while Kurzgesagt goes quality over quantity, and with things like Patreons. So I would assume people who are like-minded, like them, like they appreciate, they go quality over quantity, then they can just
and then they can
fund them directly through that.
Yeah.
And yeah, I just want to say that like things like that, I think sort of applies, and I appreciate that it's even relatively possible to set up like a
yeah, like the
that.
resources for that wouldn't have been available 30 years ago, but we wouldn't have the systems in place, I think, to have a small group of people hosting this kind of material, so, or hosting and supporting it, so it is cool. We're approaching the end of the show. Was there anything you wanted to was there anything else you wanted to say, or anybody else wanted to get their perspective on these things?
I wonder what will be the next episode. That's the only thing I would think of.
Okay, well, we still have to figure that out, so it'll be a surprise to everyone.
we do have some suggestions.
Well, I have a suggestion. It's actually a pretty good one. It's just like I don't know if anyone's gonna really take it.
Tell you what, tell us after the show, will you? And then we can.
I already did. I think I did weeks ago. I actually suggested what's the public's perspective of VR. That would have been my topic suggestion, and it's actually really good.
All right, we can talk about that more. All right, so I guess we're wrapping up.
Before we do, is there anything you wanted to get into? I know before the show we were talking about things like intellectual honesty issues, or I think you said you know someone who does science journalism and the challenges they face.
Oh yeah.
Anything there?
I didn't get a chance to talk to her, although maybe I should, and that would be cool to bring her on. But yeah, I have a friend who comes from a science background and went into science journalism and finds a lot of challenges in conveying information. One of them is the conflict of interest stuff, where actually now she goes and tries to talk to groups like the EPA and other governmentally associated scientific institutions, and is told that we can talk to you, but we have to vet everything we say. We have to run it, like we have to get permission from the White House and administration before we can talk to you about these things. And so she's running into political obstacles there, and yeah, like intellectual honesty is tough. Like and that goes back to the like the purity of science versus the conflicts of interest. It takes an effort of will. It takes a
Discipline.
yeah, it takes discipline to be intellectually honest, because you have to be able to acknowledge and accept things that are true that you might not want to be true. Emotionally, just for humans, that's a very difficult thing to do, and you're only going to do it if you believe in the principles behind that, and the principles. Yeah, they do have to do with what you believe that science is for, and how far-reaching your vision is of what the goal is.
Yeah, so psychologically, it's very easy for a person to deceive themselves. But like there's a famous quote from an author called Upton Sinclair, who said, "It's difficult to get a man to understand something when his salary depends on his not understanding it."
Yeah,
And
yeah. I think,
he wrote a book about I think it was these large cattle yards and the bad working conditions in them, and
that sounds
I guess
familiar.
when they're being developed, yeah, it was called The Jungle. But I see things that can apply to all over the place, like certain industries that may pollute a lot. You simply, that a lot of people working in an industry like that won't even consider that it could be harmful because it pays the bills.
Right, and so it's not in their interest to consider that. But I think that's one of the goals of science communication, that, to convey that there's a bigger picture here. There's more at stake than just the financial success of any given entity or institution. Like there's a bigger story here. There's a bigger legacy to leave behind for this work.
It's true, and we don't really get useful information for ourselves by deceiving ourselves either.
Right.
You can't really apply a lie to something.
So hopefully the science communicators out there will help with that discipline. Yeah, in the meantime, I'll look into that citizen science stuff, and yeah, make sure to join us on the Discord if you guys have anything else to contribute to the conversation. I think we'll probably leave it at that. So thank you for joining us, and yeah, hopefully we'll see you next time. Should we get a picture? Here, so which picture should we do? The
Yeah, you're gonna be in a picture again. I'm gonna be in another picture.
YouTube one.
After so much time.
Which picture should we have?
I have not been able to make it to him. I think that one. I like that. You wouldn't really be able to see the text for this one though, with all of us standing in front of it.
That's okay.
You stand behind it.
We'll get the idea.
Oh, yeah, okay. I'll stand behind it. Here we go.
Well, then that defeats the purpose.
It's fire. It's about looking cool.
All right, ready when you are, Ghoster. What should we say?
Trying not to scare anyone.
She blinded me with science.
For science.
For science.
For science.
For science.
For
science.
science. For science. Woo!
Science, yeah. The show.